model-based tester foundation level exam also, and he will speak about TTCN3 and model-based testing, that how can we generate TTCN3 tests via model-based mode. Please.
Thank you for the introduction. So as I said, I'm Abbas Ahmad, doing a PhD on model-based testing. My main topic is model-based testing for IoT Internet platforms. And as part of my research, I was able to do some model-based testing on the 1M2M platform, which was introduced recently by Georgia. What we're going to see in the slides today is I'm going to show you an introduction to model-based testing for IoT platform. And I'm going to show the research done and the use case we have done on 1M2M model-based testing, what we have done on in South Korea interop event. I'm gonna speak a little bit about the barriers of model-based testing in 1M2M, and it's in general the barriers of model-based testing, but specifically in 1M2M. I'm gonna show some results we have obtained in the 1M2M interoperability event, and then why are we testing the IoT? The IoT, because it's big. Gartner says there are 6.4 billion devices in 2016, and we are expecting 21, some say 50, some say 200 billion. We really don't know, it's a little bit, but we know it's growing fast, and for the last info we have, it's like 63 new devices connected per second. That's approximately 5.5 million devices that are connected every day. So, what's the problem? IoT are vulnerable. You have seen last week, I don't know if you have seen that the DNS was attacked by IoT. The hacker could breach in and attack the servers, making Google and other websites unusable. Juniper Research says that the cost of data breaches will reach $2.1 trillion globally by 2019. And this is just one example of vulnerability. We're not thinking about privacy of data, and you can imagine all sorts of vulnerability when it comes to IoT. So, how are we testing the IoT? So we are using model-based testing. I demonstrated that it was scalable and suited for IoT platform in my last year poster I took with the IoT interoperability model-based testing. The use case was on another IoT platform, not 1M2M, it's Fireware, it's a European Union initiative IoT platform. The MBT enables us to have the generation of automatically executable test scripts in TTCN3, SOAP-UI, or whatever scripts you want. The model-based testing for IoT platform will rather target IoT platforms because the devices are too heterogeneous. We have many interoperability issues, and the IoT platform tends to be standardized, as Georgie just presented us the 1M2M standard for IoT. Now I'm going to speak a little bit about our 1M2M use case. First, I'm going to introduce Easy Global Market, my company where I'm doing the PhD. A little bit, we are really active in contribution to the 1M2M testing topics. We are contributors and reporters on 1M2M security test specification within 1M2M testing group. We are active member of the 1M2M test tool group. And we have found some difficulties testing 1M2M. while doing the model, we have some problems defining a correct abstraction level because our models are abstract. And what we have found also while dealing with one previous case is that it requires many pre-configuration in order to implement model-based testing on existing platforms. So it's not really user-friendly to implement something which is already running, but I'm going to show you how we can overlap this problem. So here, in general, what it is done. The main goal of Easy Global Market is to produce the one end-to-end standard here, functional and security standard. It is the automatic production of TTCN3 code, and we have also from the same models we can produce some user-friendly documentation for manual testing, for example. It can come in HTML, Word, PDF, or whatever other format you like. How it is achieved? We manually take from the 1M2M specification, we extract some functional and security test purposes, where we're going to inject them in a model-based testing model. We inject those security and functional test purposes into the model. Then we are using a certified, from Smart Testing certified tool in order to generate abstract test cases. Once this is achieved, we are publishing the standard in the required format. For example, we are publishing automatically TTCN3 code or user-friendly documentation. This format is then given to some test labs and run on some test tool. For example, the tool which was introduced by Georgie is Titan, and you can see here performing Azure any other test tool in order to have a certification. And what's important also to note is that the model-based testing tool actually enables us to keep an overall traceability of the executed tests over the requirements. So we know, for example, an implementation of 1M2M is covering which parts of the specification. So we know what has been done and what is left to be done. So, just to sum up, the MBT tool offers to publish abstract test cases in many different formats, such as XML, HTML, JIT, and others, TTCN3. And the MBT tool has an API to produce custom TTCN3 abstract test suite, which will be then adapted to run on the test execution tool. You have to note that the automated TTCN3 code generation implies a really low maintenance cost, and this is really great because 1M2M tends to be standardized, but it is still evolving, and it still have some modification with the technical plenaries and the interoperability events. Some modification, and we have seen in South Korea that sometimes the standard evolves a little bit, changes a little bit, and that has some implication in all the tests that have been created manually. So when you generate automatically the test, you just have to only change the model. Only change the model, and you have directly all the TTCN3 code generated. This is a small example of TTCN3 test from the MBT abstract test. I'm not going to speak a little longer on this, but this is just to show you how we can pass from the abstract test to TTCN3 code. So we take the same test case, and then the test steps in the test case will be changed to some actions on TTCN3. For example, registering the AE on preamble, and then sending the request, and then making the verdicts to pass or fail, or we also have a timeout in case we don't have a response on the other side. Let's speak a little bit about the barriers of model-based testing in 1M2M. So let me just introduce a little bit the current status and the common issues in 1M2M testing. 1M2M has a complex organization, 3 committees, a technical plenaries, working groups. The implementation of the test purposes, the production and of TTCN3 writing is long, it's expensive, it takes time and will to do. We have a high maintainability cost. The quality control of the generated test cases is quite expensive because we have to manually trace test cases that have been produced to which we have to match them against the standard. And it's overall a huge resource investment. This is how the flow goes. It's from the requirements, we manually produce test purposes, then write the TTCN3 code, compile them using a test tool, and then we execute them. What we want to do in MBT is to change the flow and automatically produce test purposes, model-based test purposes, model-based TTCN3 code, compile and execute. So this implies this cost-efficient test generation process, and they provide high-quality test suites because we can keep the traceability of the test of the requirements coverage. And as I said before, the TTCN3 code generation is easily maintainable when it is automatically generated. Here are some of the results we obtained in the second interop in South Korea on May 2016. We had about 20 participating 1M2M standard implementers. We also had, like Georgie introduced, we had conformance testing sessions. We had 12 sessions with the 11 1M2M implementation tested. MBT, we were able to generate 22 test cases with MBT. As previously said, the goal was not really to test the implementation, but it was rather to test the test cases to see how people would react and what's their opinion on the conformance testing. The experiment showed the feasibility of the MBT process, that actually we can execute model-based testing on the 1M2M standard. And what's the problem is that we wanted to show that MBT could provide at least identical or better service to manual tester, and this was confirmed that we could actually have good test cases. This is just a small preview of the Titan tool which we used in Seoul, the results actually. I cannot go into details. We have a little bit hidden the real reasons of failures, because we have some non-disclosure agreements with the participant, but this is just to show you a little bit what are the results we can have for test cases. We have the results pass, fail, and conclusive. So just to conclude, just want to our experiment showed that MBT is suited for IoT platform testing. We were able to have an increase in quality and traceability of generated tests. The approach showed us that it is effective and efficient. And we have a midterm return on investment while using MBT. This small graphic is taken from Bruno Lejar, which is also my PhD director. They made some research and said that we have a break-even point after 3 iterations on generating test cases with MBT, where it is more rentable to use model-based testing. We were able to confirm that with our experimentation. And that's all.
Thank you so much. We are a little bit behind the schedule, but I think we have time for 2 questions. Okay? Questions? Emmanuel?
Yeah, thank you. Emmanuel Godin from Pragmadev. I had tell me if it's right, people working at Etsy, but when the GSM standard came out, I think they were already using model-based testing. They were actually designing the GSM protocol in SDL and generating the test cases semi-automatically, semi-model-based testing. But then I don't know why, after that, Etsy dropped the model and just wrote the test cases manually. And now you're coming back to model-based testing. So it's like a general remark on people working at Etsy. Maybe I'm wrong, please correct me if I'm wrong, but I have the feeling you were doing model-based testing, sorry, in the 90s, dropped it in the 2000s, and now you're coming back to model-based testing.
I understand I cannot respond for Etsy, in particular because I'm from EasyGover market, but what I can say about model-based testing, Stefan presented it as something yesterday. So the problem with model-based testing it has a high cost to initiate. The first steps is very expensive. We have to form people because not everyone knows to do model-based testing, and the most expensive thing is actually to build the model, to understand the standard, build the model, and after you begin to generate some tests, it becomes more rentable with time. But maybe this was some sort of barrier. It's the initial cost, which is really maybe I cannot.
I think that Stefan wants to answer.
Please.
No, I don't want to answer. I think I would just want to clarify the question. I think the question Emmanuel has, were the models that you were using standardized? Were they part of the standard, or was it the test cases that were standardized in this event? So the output, or was it the models? Or I think that's his main question.
Okay. Okay, thank you for the clarification. The model is actually a representation of the standard. So the model is a standard.
And is it an annex in the standard?
No, it's not an annex. It's really separated from the standard. We are producing the test cases which are the standard in order to have a certification, but it is not part of the one and done standard. For the GSM, in the 90s, I was born in 1990, so.
Okay. Thank you. I think we have to switch to the next presentation. So our next presenter will be